All right, students of mine, today we're looking at 5.6 day 2, the last section in chapter 5 and the last recording I'm doing today. Woo! It is 9:55 and I've been at this for hours. All right, so you don't really care about that, I'm sure. So 5.6 day 2 is about graphing quadratic functions that are not just in that same format we had last time, all right? We're going to be graphing them in a different format. And I'm also going to show you how to do this on your calculator, so that can be very helpful for you. So, as always, I have already answered your homework questions probably, and so we are not doing that, and I can't do that, obviously. So then we're going to find the vertex of a quadratic when it's in standard form and when it's in vertex form. That's very helpful. If we know how to find the vertex right away, then we can give a rough sketch really quickly, right? So next, we're going to learn how to graph a quadratic in standard form by hand and by calculator. So here we go. You should write all of this down. Determining the vertex of a quadratic. In vertex, this is called a vertex form. The form we've been working with to find transformations of quadratics is called vertex form. And the reason is because it is presented to you in a way that you can easily, quickly identify the vertex. So, you've got this regular format we've been working with. This h value here and this k value here tell you what the vertex is. And here's the layman's explanation. The value you see here, it's the opposite of this value, comma, this value here. That is your vertex. So this is a positive one, so it is a negative one, opposite of that value, comma, this value here, which is a negative 2. There is a reason for it. Typically, when I explain this reason, students get more confused. They're like, I don't understand built-in negatives. I have no idea what's going on here. But I'll go ahead and explain it. If you're the type of student who gets easily confused, just like skip ahead until I've scrolled down, right? So if you're the type of student who's like, yes, give me this knowledge, then here is how I'll explain it. So look at the formula. The negative sign is built into the formula, right? That means to put your function into this format, you need a negative here. It cannot say positive. It needs to say negative. So you need to be able to rewrite this into this format where there's a negative sign here. And the only way to do that without changing your problem is to write it like this. 2 times x minus. Now you're thinking, what can you put here that when you take x minus the value, you get x plus 1? Well, the answer, my friend, is negative 1. How tricky. So what happens is, and technically this is a plus a negative 2. So here's the idea. Notice how we have everything we need. We have got that built-in x and the built-in negative, the built-in x and the built-in negative, the squared, which we've got, the plus, which we've got, and now I'm claiming that the vertex is the h value, and the h value is just this number here, that number right there, which is negative 1. And then the k is this value here after the plus sign. So that would be this value here after the plus sign. That's how you get a negative 2. You add negative 2. And that's how you get a plus 1. You subtract a negative 1. And that is where these values come from. All right? That's why in the layman term you take the opposite of that number, because it's always going to turn out to be that way. And that's how I encourage you to remember it. Yes, the explanation does help your understanding and helps you understand things more in math, but it's shorter to remember it. It's just opposite of the number in parentheses here. All right, so let's move on. Man, I really like this highlighter. It's like little Christmas lights. It's like this light glow. It really is like a glow. So anyway, forget all that. Just me going off on some dumb tangent. So standard form. This is standard form, the despicable, terrible form that I don't like for graphing anyway. So here it is. Here's your standard form. but it's also familiar to us. We factor things in standard form. We use the quadratic formula in standard form, right? So we've seen it. Now this formula here, I'm pretty sure I will give this to you on a test. If I tell you to find the vertex of a quadratic, I would give you this formula. So here's the idea. When you're in this form, the x value of the vertex can be found by taking negative b over 2a. That's the x value of the vertex. Then the y value of the vertex, this f of negative b over 2a, that is simply the y value you get when you plug in negative b over 2a for x. So first off, you do negative b over 2a, so those will be numbers, negative b and 2a, so it'd be a positive 8 over 2 here. And that's going to be some whole number, or not necessarily a whole number, it's going to be some value. Then the y value, all you do is you plug in this value for x and you see what you get for y, and that's what the y value of the vertex is. So the steps are right here. You should write this down, absolutely write this down. So you're going to find negative b over 2a. So a is 2, b is negative 8, and c is 15. Not that c is going to come into this, but that's a, that's b, and that's c. Remember back to the quadratic formula from 5.5. So negative b over 2a is negative 8 over 2 times 2, which is 8 over 4, which is 2. All right? So that's negative b over 2a. That is the x coordinate. That is the x coordinate of your vertex. Now we need to find the y coordinate of your vertex. And to do that, you take this value and plug that into x and find y. So you're going to plug that into x and find y. So y equals, that looks kind of like an x, y equals 2 times 2 squared minus 8 times 2 plus 15. You could use your calculator for all this if you wanted to. 2 times 4 minus 16 plus 15. That's 8 minus 1, which is 7. So you have 2, 7. That's your vertex. All right? That's it. That's finding the vertex. I know I say that's it, but it just follows the formula. Man, my back is starting to hurt from sitting in this chair for so long. All right, so find the vertex of the following function. This is in vertex form. So you go ahead and tell me, can you tell me the vertex of this function? That's back up here to this one here. So look at this, and then look at the example. Look at your notes. What is the vertex? It's the opposite of this number, comma, whatever number is over here. And technically there's like a plus 0 here since you don't see it. So it's negative 5, comma 0. There's your vertex. Okay? Opposite of this number, comma, whatever number is here, which is 0. Now, vertex of this, harder, takes longer to do. Negative b over 2a. We need to find that. A is, B is, and C is. What is A? Look at the problem. Tell me what A is. Or think about what A is. Obviously, you're not going to tell me. You're not going to be like, Mr. Dybel, you told me to tell you this, so I'm telling you A is 1, B is negative 10, and C is 24. But like, yes, thank you, child. Negative 10 and 24. So, plugging those in, negative b over 2a is negative 10 over 2 times 1, which is positive 10 over 2, which is 5. So the x value of your vertex is 5. The y value, remember, plug 5 into this x and this x, and you get y equals 5 squared minus 10 times 5 plus 24. And that is 25 minus 50 plus 24. That is 29 minus, wait, not 29, that is 49 minus 50, which is negative 1. There you have it. Now, let's figure out how to graph. Actually, do I really want to go over this? It's such a pain. I'll give you a brief explanation, and I won't have you do it by hand, but I will require that you know the gist of how to do it by hand. Okay, so you should have an idea of what you could like. Actually, you should know what to do. You should just not want to do it because it's annoying. Okay, so I'll explain what to do, and then you can see how to do it, and then we're going to use our calculator. All right, so graphing quadratic functions in standard form. Now, here's the idea. You don't have to write all this down. Just follow along. Pay attention. Don't skip this. So, you would find the vertex using the same method we've been using, right? So you'd have this form, and then you'd find the vertex exactly how we just did. Then you would plot that vertex, okay? So say the vertex was, actually, we'll just go ahead and do this one. Say the vertex was 5, 1, which it is, right, in our example. So you've got 5, 1. 1, 2, 3, 4, 5, 1. So there's your vertex. What happens is, if you have not noticed so far, parabolas that look like U's, they are symmetrical. If you drew a line straight through the vertex, that is not straight. Straight through the vertex. And then flipped, like folded your piece of paper along this crease, it would lay directly on top of each other. These two different sides, and that is because this is what is known as the axis of symmetry in a parabola. It's a line directly through the vertex. All right, if you drew a tangent line at the vertex, the axis of symmetry is always a line perpendicular to that spot. So, for any of you technical people who are like, I'm a teacher and I'm looking in to see how accurate this young teacher is. Well, there you go. Take that. So, anyway, here's your vertex, and so you'd have a parabola. And right now, we don't know how the parabola looks. Here's the drawback, right? We can't draw a general idea of the parabola because it's not in the format we understand with transformations. So instead, what we have to do is you have to test a point to the left or right of the vertex and plot it. So if you look, this is the value. This is 5 comma. Wait, this is positive 1. What am I smoking? This is supposed to be negative 1. What are you doing, Cody? This is supposed to be negative 1. All right? So here's the idea. This is 5, negative 1, right? And our goal is to figure out, does the graph sort of look like this, or like this, or like this, or like this, right? We don't know. So what we want to do is we want to test some x value. So this is the x value of 5. You want to test some x value that is close to 5. My recommendation is 2 away from 5. So the value that is 2 away from 5 that I will use is 3. So I will test x equals 3. So I will plug in 3 for x. So I'll get 3 squared minus 10 times 3 plus 24. And that's going to get me 9 minus 30 plus 24. And that's negative 6 plus 9 is a positive 3. So after I plug in 3, I get positive 3. So then at x equals 3, your y value is 3. So your graph is going to be at 3, 3. And if you drew a U going in this direction here, it's going to get mirrored over this axis of symmetry I was talking about. So there's an axis of symmetry here, and it's going to mirror over it. And so it's going to look like this on the other side too. And that is how you graph, okay? That is the idea of how you graph. But your calculator can do this for you. Okay, here is how you do it on a calculator. So test a point and graph it and mirror that point over the axis of symmetry and sketch. That's what we did, all right? So the calculator I will go through all of the steps on the calculator. So follow along as with my steps on the calculator. So first off, here's the idea. I'm going to put my pen down. So first thing you want to do is you want to press y equals, and you want to clear anything out that you've got in here. Then you want to put this into your function, or into your y1. So here's y equals, so this says y equals, and you want 2, can you press x? No, that does not work. 2x squared plus 4x plus 5. All right. Then here's what you want to do. You can find the vertex of your graph using your calculator. And here's how you do it. You press graph and you look. You have to make this decision. You have to be smarter than your calculator. You have to look. Is the vertex a maximum or a minimum? Is this point here the maximum value that my graph will touch on the y's, or the minimum? And you should see that it's like a dip. It's like a valley. It's the minimum. So you want to find the minimum. And here's how you do it. You press second, trace, and we are finding minimum. And this is how you do it. You press enter on the minimum, and it asks left bound. See how it says left bound? What this is wanting, there's this cursor. See how there's this cursor here that I can move left and right on my graph? It is wanting you to go left of this minimum. So left bound means you go left of the minimum. So it doesn't matter if you're going up and down, because it's going to follow the curve, but just make sure that this dot is to the left of the minimum. So right now it is to the left of the minimum. So I'm going to press enter. And now it asks for a right bound. So you need to move your cursor using the arrows to where you are right of this value here, and press enter. And then press enter again on guess. And it tells you you are at negative 1.00. Ignore, if you ever see your 0.0000 something, ignore that. It's just negative 1, 3. So give me a second, I need to cough. All right. It is negative 1, 3. So that's your vertex. Negative 1, 3. And now you can put that on your sketch, negative 1, 3. And then you can sketch accordingly. If you want an accurate sketch, there's a way to do that. Look at the table. If you're wanting an accurate sketch, check this out. Press second and then the graph button, and it pulls up a table. And so all you have to do is start looking at numbers. At negative 3, it's 11. At negative 2, it's 5. So let's plot that. At negative 2, it's 5. At positive 2, I imagine, it's 5. No, wait, whoa. Or wait, no, at 0, it's 5. Yeah. So at 0, it's 5. And so you draw your U. Look at that. You can be as accurate as you'd like with this table here. And there you go. There's your sketch. All right. I'm not going to go ahead and do this next one. You would do it the same way. Use your calculator. You could find the vertex manually using this formula here, or you could use your calculator. And here's your homework. Now, there's special instructions. On these problems here, I want you to only find the vertex. Then, on these problems here, I want you to find the vertex and sketch a graph. Okay? And sketch a graph. There's your homework. This is the end of the chapter. Thank God. All right, so we're done with chapter 5. Chapter 6, I think, is it is going to be the last chapter we cover in this semester. And I'm not sure what month it is right now, where we're at in this semester, but hopefully everything's been going okay. This will be my first year doing this, so, you know, there's going to be some learning. But there you go. Have at it.